Okay.
Welcome, everyone. Today we have Victoria. I would like to thank to her. She is in the middle of submitting and finishing her thesis. Usually it's a very, very stressful period. Thanks to her. She designed the game. She went to school, implemented that several times, so she has full of experience. So if you have questions, just don't be shy, don't hesitate. Yeah, this will be our second online session, and I hope not only you will learn, but also it will be inspirational. So thanks, Victoria, yeah, accepting our invitation. And now I will give floor to you. You can share and start.
Okay. First, thanks, Abu, for inviting me to speak today. So hopefully,
regarding questions, we should wait some point, or
yeah, maybe we can wait at the end.
Okay, at the end. Okay.
Yeah.
Okay, we will follow it. Thank you.
Perfect. Thanks. Okay. So just to check, can you hear me well? Can you see all of this?
Yes, we see and we hear you. Thank you.
Okay, perfect. So yeah, today I'm going to tell you my experience on designing quantum games. But first, let me tell you a bit about my background. So I have a bachelor in physics by Universidad de Valencia in Spain, where I am from, and also a master's in theoretical physics at Universidad Autónoma de Madrid, also in Spain. And currently, I am almost finishing my PhD in quantum games at the University of Galway in Ireland. And my supervisor is Dr. Michael McEdry. My PhD is in quantum games, but it is in a research area in theoretical physics. It has nothing to do with designing games, which is what I'm going to talk about today. But in my PhD, it's just a research tool. If you're interested in this research area, you can just go and check this review. It's very comprehensive, very complete, and it gives you the full flavor of the field of quantum games. So I am also the founding member of Q Ireland, and I was the main coordinator until last year within Q World. So yeah, we started it a couple of years ago. Just be aware, I am not a computer scientist. I am not a game designer. So probably some of you here know for subtopics much more than me. So be aware of that. My first experience with a quantum playable game, I do games, but they are not to play per se, was during an online jam in September 2021 that lasted the weekend. So it started on Friday midday until Sunday midday. So it's this one, the Online Quantum Game Jam 2021. And we had to prepare a game in that period of time and then present it. One of the sponsors of this game jam was QWorld, and that's actually how I found out, because it was posted somewhere, and I said, wow, that looks very, very interesting, so I'll do that over the weekend. So to design the game, first you need a team. So the team, there were three of us. It was Andy Dodson, who was the game developer or programmer. I'm not sure if he does that for a living, but he's very interested, and he was a great programmer and game developer. We had also Nora Heiskanen, who was the visual artist, and then it was me as the quantum physicist. And this team, the three of us, we produced this game called Heisenberg's Bicycle. So Heisenberg's Bicycle, this game, is based on Heisenberg's uncertainty principle back in 1927, which is this equation that you are seeing there. where the sigma x is the uncertainty in the position, the sigma p is the uncertainty in the momentum is the mass times the velocity. You can think of the uncertainty in the momentum as the uncertainty in the velocity also. And then we have Planck's reduced constant h bar. So this uncertainty principle is telling you that the product of those two uncertainties should be greater than a constant. One way of interpreting this equation could be that the more precisely you know your position, the less you know your velocity. That means if you know precisely your position, that means that your uncertainty in the position is very small. And since the product with the uncertainty with the velocity should be greater than a certain quantity, that means that your uncertainty on your velocity should be higher. So that's what it means. A very like a pictorial image of this could be, imagine that you're in Galway, which is where I'm based on. My PhD is there. Imagine that you know your position. I'm not sure if you can see my pointer. So you know your position, that red point there, but you don't know how fast you're going. So your speedometer there is kind of blurry. So that's one way of thinking about this. On the other way, you could think that the more precisely you know your velocity, the less you know your position. Same picture, if you're in Galway, you're somewhere in Galway, you don't know where you are, you don't know your position, but you know how fast you're going. So that's the pictorial image of Heisenberg's uncertainty principle. And this game is more or less based on these two images. Of course, designing a game is not very easy, and especially when you have less than 2 days to do that. So we use this game design notebook, which you can find on that link. And there we kind of started brainstorming and talking what we wanted, all of the ideas that we had behind that. And yeah, same, more pages. Again, it's available on that link, I think, so you can check it out. But of course, we had to do a lot of planning. So at first it was called Heisenberg's car, but we wanted to be more environmentally friendly, so we decided to change it to a bicycle. Then we recorded all the meetings that we had, all of that for the jam. And finally, yes, so we managed to what had been done, what needed to be done, all of that. So that's good also to have a planning. This is an idea of how we implemented that. So imagine that you're here, you're Heisenberg. Are you seeing my pointer, my mouse there?
Yes, we are seeing.
Perfect, yeah. So you are there, you are Heisenberg with your bicycle, and you're at an initial position, and you need to arrive to a final destination. And there are some trees in the middle. So you're asked in the first stage whether you want to choose your direction or your velocity. So imagine that you choose a certain direction pointed towards your destination. Then you are assigned a random velocity. You arrive at a certain place, and then you're asked again. Imagine that this time you choose a velocity of 5 meters per second, then you're assigned a random direction, and so on. At each stop, until you reach your destination. So that was the idea. And this is what we managed to do with Andy, mainly using Unity, with Nora with the visuals, and me with the ideas and all of that. So I hope you can see that. So that's what we did. So you start picking a velocity, for instance, when you start. Okay, yeah. you start picking a velocity, let's say 25 meters per second. Then you should go, you assign a random direction. And here you have also the map. You see where you are and when you need to be. You're asked again, then now you choose the direction in degrees. And then you're moving around in the map. And you'll see that you have here some turns. So you need to arrive at your destination within a given amount of turns. So yeah, that's it. Just so if you're out of turn, then you lose and you can play again or quit. Okay. So this game, I think it was quite hard to win actually, but I think Andy managed to win a couple of times. Here we have the screenshot that it is possible to win. This game is publicly, you can check it out. It's very, very simple. Again, I think it's hard to win, but it was just made into less than 2 days. So I think it was pretty amazing what we did. So for this experience, I learned a few things. First, to keep it simple, our idea of the Heisenberg bicycle, it was very simple. And again, it's important if you have some time constraints. Then that our team was very varied in terms of expertise. So we had the programmer and the game developer, the visual artist, and me. So we could kind of, all of us could play a role in producing the game. And finally is to ask non-experts and to speak with them. Me particularly, in this case, we didn't have much time to ask for feedback, but me particularly as a quantum physicist, when I was talking mainly to Andy, the game developer, it was very enriching because he was not an expert in quantum stuff, but he knew how to program games, and his vision and mine, we had to talk to each other. So it was very, very enriching for both. And I think we managed to understand each other and to reach a middle ground. So that's it. So I've been talking for around 2 minutes or so. So I'll take a small break, but I'll leave you to do some task. So I'll ask you to guess the 3 films that I'm going to show you now. It's mathsy based. And I'll give you a few minutes. So here you are seeing 3 pictures. Each of them corresponds to a film. I'll give you a few minutes, and then we will resume. I'll give you the answer. So, okay, I see someone is posting in the chat. Yeah, okay, yeah. Give a few minutes to the other players in case they haven't figured it out yet. Okay, yeah, you're trying. Okay, let's start with the easy one. The easy one is the first one. Someone said it. The first one is Matrix. Yeah, 1999. That was the easy one. Probably for the second one, anyone? Yeah, someone said 1 Mile. Yeah, close, close. Anyone would like to guess? 1 Mile to you. Yeah. Almost, you're close. This is a bit harder, that one. It's the Green Mile, because the words are in green. That was a bit hard, maybe. Also from 1999. And what about the last one? The last one is very, very hard, I'd say. Oh, well done, Alberto. Yeah, that's WALL-E. You have, oops, yeah, you have the wall and then the number E. is WALL-E from 2008. Very, very, I really like that film. Yeah, well done, well done. Okay, so time's up for this small interlude that I like to do. And let's continue. So I said that I'm the founding member of Q Ireland, and I was the main coordinator. So in Q Ireland, and Q World has produced all of these amazing workshops that are meant to teach people to program and to do quantum computing and program. So that's what we did. But if you think about it, all of these amazing workshops are mainly for adults. These workshops are joined by maybe university students, late teenagers maybe that are interested in programming, older people who are just interested in that, but they have some experience in programming or are very, very into that. So that's great. But I wanted to engage the children. So I was thinking of how can I engage the children into quantum. So that was my idea. How can I do that? Lucky enough, the answer was in me doing the PhD in quantum games. It was in the research area, but over the years I came across a few papers, and one of them was the quantum tic-tac-toe. This paper, teaching metaphor for superposition in quantum mechanics. You have it there, you can check it out. It's from 2006. So when I saw that, I said, oh, maybe I have the solution. So I'll use this quantum tic-tac-toe. It's very simple. It's a game that everyone knows, everyone is familiar with. Tic-tac-toe, you may know it as maybe noughts and crosses, X's and O's, or however you call it in your own language. But it's almost universal, I'd say. So everyone knows the rules and how to play more or less. So that was my idea. I said, oh, in Heisenberg's bicycle, we use Unity, so I'll do that. I'll just program my own version of the quantum tic-tac-toe in Unity for the children. So that's great. So that became my Christmas project 2021 to do that. The first thing is that, Victoria, you don't know how to program games. That was the first thing. So I have no idea. But for my work, I know how to program more or less. I can learn. And thankfully, Unity has a lot of materials and tutorials, and one of them was a tutorial of creating a tic-tac-toe using only user interface components. That's fantastic. That's my lucky. So I'll follow this tutorial, and then I'll tweak it. I learn how to program in Unity following this tutorial, and then I'll tweak it to make it the quantum version. Unfortunately, this tutorial specifically is no longer available. I just checked 2 days ago, but there's plenty of tutorials of Unity, and this one, tic-tac-toe, I've seen a couple of videos out there. So after some time, I managed with this tutorial to program the tic-tac-toe. This is what I did. So if you go to Unity, and then this is what I programmed in play mode, then you choose to start, and then you start playing. Super simple. The usual one that we all know. But I programmed it myself, and I had no idea of how to do that. So I was very proud. So yeah, this game is quite boring. So after some time and some frustration and tiredness with Unity and myself, I managed to program this version with the quantum rules. So this is what I did. So here you start the same. You start with choosing who starts. And in this case, you have two moves, the small x, x1 that you can put in two spaces. The same for O, and then you start putting things. And one of the moves, one of the possibilities is to choose to measure one of the previous moves. So in this case, O is going to measure the first movement, O1. Oops. And what happens is that between those two possibilities, one of them is picked. So with 50% chance, one of them is picked. And then you win if you pull all of the big squares. So here you can see, going very fast, yeah. Yeah, so that's it. And that's what I did. I was, again, very proud of myself. So that was just playing, super simple. But then there's a lot of extras. First is the design. So for the design, for the fonts that you see here with these kind of more pixely letters, I use the website DaFont. It's free. You can check out. They have 10,000, a lot of fonts that you can use for free. You can download them and then use them. That's what I used. Also for the buttons here, you see that there's the blue button for the menu, the measure button for in green, and all of that. I use a Freepik. They have paid version or paid assets, but some of them are free. So I put the free ones. And again, if you want more websites, you can check out these two websites, but you have lots of resources on the website of DisQJam. So don't worry about that. There's plenty of websites to find the assets that you need for your game. So that was design, but I also added the background and the titles, and I did it myself. I use my own tablet and I like drawing, so I did it myself. Then another extra is the features. Besides the plane, I added a main menu that you can see there with the title and all of this fancy or background. The button to play that takes you to directly play. The button to how to play with all of the rules. The button to learn more about the quantum wall. That's the main ones. So in the part of how to play, I wrote all of that, and you can even scroll down. There's a lot of text, and I thought, oh, this, I think it's clearly explained. It's understandable. I asked my housemates, and they were very blunt, and they said, hey, that's super boring. No one is going to read that. And I said, you are totally right. I would never read that. So what I did is, okay, I'll add some button here, which is the visual explanation here. So in this example, you are taken directly to a play, kind of with arrows, and it's more or less explaining what's happening. So with screenshots that you can pass on, just move to the next one or move to the other one. So here you see that you have to play. So he's kind of explaining what is happening, the measurement, the 50% chance, all of that. You can pass it on, go back. So this kind of structure is more for someone who already knows how to play or knows the rules and what's happening, and they can kind of use it to maybe explain it to someone else. So that visual example explanation, I think is very, very handy, but still it's also good to keep the text just in case someone wants to read it. In the button of to learn more about the quantum wall, I also added a button to see how the superposition works. So here's another video of what happens. So when you click that, you are taken to this kind of animation that you can play. So when you have this board with the two movements, two moves of x, small x's, is like if you have two boards, two different boards in which the x's are placed on those two spaces. And then with the second move, or O, you have four of those different boards, and so on. So again, this is kind of a visualization of superposition in this game. Also, I added a screen of how the measurement works. So here's what happens for the measurement. So here also you have some kind of animation. So again, you start with this, with the four boards, and then when you are measuring, if you are picked one of these x's, then the boards whose x was on the top right corner are picked. So again, this is like to help people understand and explain what's happening. And another example with measurement of O1, same thing. And you can play it, you can stop it, all of that. Then I added the acknowledgements. In the acknowledgement, there is the link to the original paper. Someone want to check it out. Then in the main menu, there's also instructor or full version. So you can pick between those two. If you click into this blue text, says that the full version contains more text and explanations, and the instructor's version has less text, so that the concepts can be explained by the instructor. That's what it means. Super simple. Basically, here, when you pick the instructor version, when you go to the rules, you'll see it now. When you go to the rules, you are taken directly to the visual example explanation. Whereas if you are in the full version, you are taken to the whole text. But you can also access the visual example explanation. So that's the idea. Then I also added some languages that you can play in your own language. So the available languages right now are English, Irish, Spanish, Catalan, Italian, French, German, Norwegian, and Polish. Quite a few. There's some button to check who translated all of that. And yeah, basically that was me asking all of the people that I know from different countries to do the translations, except Polish. She was Camila, and she was in Q Poland. So if you want your own language to be added to this game, please just send me an email, and I can add it. It's online, this game, so you can have it in your own language if you like. It would be basically how you translate an Excel file. That's it. And then I'll take care of the rest. Okay, so this is everything. So the Quantum Tic-Tac-Toe, here is the link to the game. It's also on the website, I think. And here are all of the things that it has. So it has the main menu, it has the play, has the how to play with the text, with the visual example, it has the learn more, explaining the superposition, the measurement, the acknowledgements, the translations, has the instructor and the full version, it has the languages, has a lot of things. And factoring the time that it took everything, so just to get it to play, to get this to work, maybe it took me around 10 or 20% of the total time that it took me to do this. All of the other things, all of the other features plus the design, it was most of the time, 80 or 90% of the time. So that's for you to take it into account. So what I learned from doing all of these is a few things. First, to keep it simple. Okay? So tic-tac-toe is the simplest thing that you can think of. Very simple, everyone knows it, so there's no complication. The game, it might take very, very little time of what you have planned. So 10 to 20% of the time, in my case. Maybe for you it'll be less, it'll be more, it depends. But it took me 80 to 90% of the time for the design, the features, to make it look pretty, to make it look playable, to make it more appealing, to get rid of the bugs when people were playing, all of that. The most important thing for me was to ask non-experts or ask for feedback. Okay, I was telling you, I asked for feedback from my housemates who had no background in math or physics or quantum. So they were very, but they like playing games. Everyone likes playing games. So they were telling me, oh, this doesn't work. Maybe this is too complicated. Maybe change that. Maybe. So that's how it improved. I know it's hard. It hurts sometimes because you've put your time and effort into doing things, and then you're told, oh, maybe I need to take it out. But it's for the good is to improve the game. And maybe don't be too ambitious. In my case, this game has only the superposition and the measurement. That's super simple. I haven't added the feature of entanglement. I could add entanglement between the quantum boards, between the boards, the different boards, so that when you measure one, it's entangled to the other one. I didn't do that. And still, this game is very rich, has lots of things to do. So don't be too ambitious. Don't try to teach kids or teenagers, I don't know, the philosophical implications of entanglement and the measurement of the collapse of the wave function and all of that. No, keep it simple. For me, it was more to get kids to be interested in quantum rather than teaching them actually concepts. No, it was more an introduction. So this is the quantum tic-tac-toe that I programmed. And sometime in January, I think, Abu, I will tell you how I implemented this game. And I went to, it was like 5 schools in 2022, and this year 4 or 5 as well. So it's been, I've done this workshop around 10 times, and people, the kids seem to enjoy it. So sometime in January, I can tell you all about that. And that's it. Thanks for joining today. I hope you found this useful, and I will happily take any questions you might have. Thank you.
I would say it's great. Just very practical, all information. Because I tried to convince them first make this like code to play game, and then work on this all design, etc. Just so yeah, as you said, maybe in your case it's like 15%, just the main code, but overall every other things, because also you want to go to school. Yeah. And also there is difference between jam, like weekend jam and our jam. Our jam has more time, so
yeah,
you can
nicer,
use it. Yeah. Okay. Questions, remarks. Victoria, can we get your slides or?
Yeah, of course. Yeah, I can send it to you
Because
later
you
on.
already shared also several good resources. I want to just pick them and maybe make a list for our participants as well.
Yeah,
Also,
for sure.
you can
Yeah,
share directly this as a PDF.
yeah, I can do that. Yeah, the videos no, but yeah, the links, of course. Yeah, I'll send it to you. Yeah, for sure.
Thank you. So, some question? We have a lot of time or some ideas. So very shy audience. I think somebody makes comment about quantum, Tom and Jerry. I
Oh, yeah.
suppose such a game. And he said it was hard to win as well when you explained this Heisenberg game, I suppose.
Oh, yes, yeah.
Tom has to
Yeah.
make a long enough interaction with Jerry, which wasn't possible because of uncertainty of position of the Jerry. Yeah. So it seems there is a playable game. First of all, I understand it's Quantum Tom and Jerry.
Yeah, well, I like the cartoons. Yeah, I'll check it out.
So no question.
Maybe everything's clear.
Yep, Marvin say, can we use Scratch to model the games?
I have no idea what that is. So probably
Scratch,
yes. I don't know.
Scratch is something like Unity, by the
Yeah,
way.
maybe. I'm not sure.
As I understand, Unity, you don't need to code even. Without code, you can still design, yes, and make decisions, or you write little code.
Yeah, for the quantum tic-tac-toe and all of that, yes, I had to write some code. I think it was in C# to kind of keep track of all of the spaces were filled with whatever, and then when you want to measure, then you need to choose between those two. So you need to keep track of all of where all of their small x's and are. So I had to code for that. Yeah.
Okay.
Yeah. But maybe there's easier ways to use planetary other quantum games.
Okay, Alberto say, could you explain a little about your research area? What are the quantum games from this point of view?
Okay. So yeah, that's a good question. So it's very, very, very vast. So for instance, there are many situations that you can model as games that are more practical. So for instance, when you want in cryptography, when you want for Alice and Bob to do some task, so they want to communicate a key or whatever, and then you have an eavesdropper that wants to steal this key. So for instance, you can model that situation as a game, as Alice and Bob want to play this game, want to communicate this thing with this probability rate of winning or probability rate of success, then you can model that as a game. That's one example. There's another example, very well known, which is called the CHSH game, that is based on an inequality in quantum mechanics. So it's based on some result already known. But that inequality is not very just a combination of numbers that gives that number, or gives this is bounded by that amount. But you can explain this same thing as a game. And that game in particular is called a non-local game, because when the players use quantum stuff, quantum states and measurements, they can win much with a higher probability than when they use classical resources. And that's very, very useful, for instance, to test. Is this device quantum? How do you check if something is quantum? Well, you can check that if you play this game in this device, then if it's really quantum, you should get higher probability of winning and all of that. I don't know, Alberto, if that answers your question. Hopefully, yes, but it's a very, very wide area. So it's almost almost any situation or any problem can be modeled as a game, and is a useful language.
So as I understand, it's a quite simple verification also whether this device is quantum or not.
Yeah, so kind of there's these non-local games that show a separation between the classical value and the quantum value, and that has applications in quantum cryptography, also in quantum computing. There was this paper very recently of MIP star equals to RE, so some quantum complexity classes, and they used actually the language of games to prove that, of quantum games. It's very,
That's
very,
good. Yeah.
very wide, yeah.
Agnivo asks, could you just maybe go through the resource again? Probably we can share websites later.
Yes,
Maybe
yeah.
we can quickly
Yeah, I can
list
do
down.
that. I mean, I can share the slides and then you have everything. I think that'd be more.
Okay.
Yeah.
And a brief overview of the programming part.
The programming part,
Your game probably, I suppose.
from that, let me see the programming. Okay, let me see. I'll stop sharing and I'll try to find it in Unity. Okay, still have it somewhere. I'm opening Unity. It might take a few minutes.
Claudia will have a session Monday and she will mention about Construct. As I understand, Construct provides also an environment and you can work online, if I understand correctly. And without coding, you can do several things. You can complete a game, as far as I understand. She will not maybe explain, but she will give some examples, I hope. As I understand, Unity is a little more complicated and probably learning Construct for such short time would be more reasonable, as far as I understand. I am also very new, all these things.
No, yeah, probably there are more environmentally friendly or like more friendly. So I can show you like very briefly if you want, but it will seem maybe too complicated, which it is, but it is because it has also lots of things.
I mean, we didn't suggest to learn Unity for this.
That's
we will
what
encourage
I use,
them to check Construct. Probably, as I understand, they would have enough time to use Construct for basic ideas. But Unity, we didn't suggest. If you don't know in advance,
it'll take some time. So this is only the start screen. I don't know if you can see this. So has some things that are intuitively. Let me see if I can find the script. So there's here a lot of scripts. Maybe this is the main script that controls all of that in Visual Studio. Again, maybe this will look terrible, or maybe you're familiar with that, it depends. But yeah, it took me some time and I'm familiar more or less with the language, but just to understand, I'm sure there are a lot of other software that are easier to use. So I don't know, yeah, this is kind of the coding, the main code that that takes into account everything, that does everything with the game controller. So this was all of this. So yeah, again, maybe depending on your background, this is too much or this is too little. But yeah, and again, this is because it has a lot of things. With only the play, it was much less. Yeah, I don't know if that more or less answers your request.
I guess so. I will say yeah, I mean, for this jam, if they don't have experience, we don't suggest Unity, especially.
No, yeah, no, not really, no.
Especially, we have also Q-class, and they used Python widely. Probably using some Python library would be maybe much quicker for them.
Yeah,
but there could be some participants I see that they have some experience in Unity. Then if you have some person in your team knowing Unity, then of course you can go from that direction. Yeah, yesterday also Maxim's show everything on Jupyter notebook even. So some
That's
feel
good.
even more comfortable because
Yeah.
sometimes even this Python console looks confusing to people.
Yeah.
Okay, one more question. So of course, you are a researcher. So what application it has in the quantum cryptography? I think this is about quantum game theory.
Yeah, what as I was saying, many cryptographic situations can be thought of as games. So they have to do some task communicating, and then you can communicate in, I don't know, maybe they want to communicate key or the parity of one of these one of the players, one of the qubits of the players to the other player, and you can think of that as a game with some protocols. So kind of we are given this input, we both have this input, we need to do some task, and this task can be thought of as winning this game with these conditions.
I think they can check maybe communication complexity is also
As well, yeah, exactly.
theoretical subject, and it really helps to prove lower bounds, for example,
Exactly.
to do some task between two parties. Sometimes you show that okay, there must be certain communication complexity bounds, and then you can use them and just find the answer to your question. And in case of game theory, probably people should also study this tool, like communication complexity, and then it can be applied in several teams. Okay, any other question? I think your overall experience was very inspiring, especially for me. First, you are just attending some online 2 days, less than 48 hours probably event, and then you are also seeing our workshops, and then you say, okay, maybe for kids we can do something different. You design it, you go to school, you are also like make translation, you can prepare text for like also instructors. So overall, I think it's very, very inspiring, and you are still open to include more translation. I hope some of our participants, may be interested because we have still from different countries. So probably there is an exam sheet, and maybe you can even find like partner together, 2-3 people, and you can just translate. You will be credited anyway.
Yeah, for sure. Yeah, I mean, it's prepared for that. So it took me a long time. Again, I was when you're kind of that's a nice idea to have it, and then kids also like it to have. I'll tell that more in the next. But it's also kids, that simple thing. They really enjoy it to just be able to switch even a language that they have never heard of or they don't even know. But they enjoy it. Yeah.
Yeah, after translation, of course, they can also use in their own language. I think this is very nice opportunity. A couple of translation from our jam would be great indeed. Maybe even up to 10, why not?
Yeah.
Was able to get the idea about the quantum games. Thanks for the session. Okay. If there is no more question. Okay, I mean, at least for me, it was very inspiring, as I told you. Also, you shared a lot of resources. We should pick them and then share with the participants as well. Yeah, thank you very much, Victoria, and
thank you.
hope to have you again in January or February and learn more from you. Thank you very much.
Thank you. Bye, everyone. Have a nice evening or morning, wherever you are.